Alright, to start these notes off on areas of regular triangles, you need to make sure you note that we're going to be discussing equilateral and equal angular triangles. Since they are equilateral, that means that they're 60, 60, 60 triangles. And if you see how the labeling goes, you already know what a side of a triangle looks like. But the radius is similar to the circle where you have a center of the triangle and then the radius extends from the center to a vertex. Apothem will be your new term, and apothem, as it says in the definitions, is the segment from the center perpendicular. So make sure we know that it's perpendicular to the side at its midpoint. So just take a moment to go ahead and label everything on this part that I have labeled, and then we'll go to the examples. Okay, to start the examples off, I went on ahead and worked everything out, hoping that maybe the work will help guide you to how much work is involved in solving these problems. The formula says to find the area of a regular polygon, it's going to be half of the perimeter of the triangle times the apothem. So I went on ahead and marked again our 30, 60, 90 side lengths for the triangle over here. And since the apothem is the height of just the smaller triangle, or x, that we're trying to find, I went on ahead and set it up differently than what we've done in the past, and I'll do a different setup for the next example. But your apothem is, you're going to set the 60-degree angle, which is x squared to 3, equal to half of a side length. So looking at this example, we're doing x square roots of 3 equal 9. If I square both sides, I get 3x squared equals 81. Then I divide it by 3, so now I'm left with x squared equals 27. To find the square root of that, then I've factored it out, so we have the square root of 3 times the square root of 9, which gives us 3 square roots of 3. So your apothem for this example is 3 square roots of 3. Well, then I had to find the perimeter of the shape. The perimeter is just a side length times 3, so we got 54 units. And then what's written in the blue is how many, or the formula, which is the apothem times the perimeter divided by 2. And then when you work that out, don't forget that when you put your answer in, since we're doing area now, we do need meters squared, or whatever the label is, squared, since you're finding how many square units are inside the shape. Okay, looking at example 2 to find the area of the regular triangle, please make sure we look at the information given to us. They did give us the hypotenuse of the smaller triangle, which is twice the length of the apothem. So if the hypotenuse is 8, then our apothem is going to be 4. And then we know that from here to here is x square roots of 3, so that's going to be 4 square roots of 3 for that length. So to find a full side length, we just have to double it, because that means from here to here is 4 square roots of 3. So that allows us to find the total side length, which is 8 square roots of 3. With knowing 8 square roots of 3, that helps us determine the perimeter. Perimeter is 1 side length times 3, since it's equilateral. So that's going to give us 24 square roots of 3. And now to apply the area for regular polygons formula, we're going to do the apothem times the perimeter divided by 2. And how you choose if you want to simplify first, you have options there. So I can cancel the 2 and the 4 out, and that leaves me with 2 times 24 square roots of 3. So the area of example 2 is going to be 48 square roots of 3 inches squared. For example 3, we don't have a picture, So we might want to add that to help us see what all we need to find. Since it is the area of a regular triangle, and the key word for this is regular, I do know that my perimeter is 60 square roots of 3. So if there's 3 sides to the equiangular equilateral triangle, 60 square roots of 3 divided by 3 leaves me with 20 square roots of 3 for the perimeter. So I have that information. I'm sorry, for the side length. They gave us the perimeter. So 20 square roots of 3 is a side length. 20 square roots of 3 from here to here tells us that if I take half of that, so now I have the base, and if I know, I'm getting better at my 30, 60, 90s, if the longer leg is x square roots of 3, then the shorter leg is x, so my apothem for this one is 10. So to find the area of this regular triangle, I have apothem times perimeter divided by 2. So however you want to approach it, again, if you want to simplify first, then divide 10 by 2 and you get 5 times 60, or you can multiply it out and then divide by 2, but our final answer is going to be 300 times the square root of 3 centimeters squared. Okay, for the last 2 examples of these notes, I feel like it gets a little bit easier because they're giving us information that will, to me, make it a little bit easier to solve. But let's go ahead and start off with drawing the picture. Remember that your apothem is from the center to the midpoint out of the 30, 60, 90 triangle. So our apothem is 2 for this one. With that information given, now we know half of a side length, because we're going to do 2 square roots of 3, which means since it's at the midpoint, this is 2 square roots of 3. And if we combine those, then we know a full side length is 4 square roots of 3. And that'll help us determine the perimeter, because perimeter is side length times 3. So for this one, our perimeter is 12 square roots of 3. And remember, to find the area of a regular polygon right now, it is apothem, for this one is 2, times the perimeter, divided by 2. Since our 2's will cancel out, the area of example 4 is 12 square roots of 3 feet squared. Alright, we're almost done. Example 5 wants us to find the area with a radius of 10. And if we go back and look at the first page of our notes for the labeling, the radius is technically the hypotenuse of the 30, 60, 90. It extends from the center of the triangle to a vertex. So since we know that, that's twice the length of the apothem. So now we know the apothem is 5. We know that the longer leg is 5 square roots of 3. So if I double that, then I know that the side length is 10 square roots of 3. So if I take one side and I triple it, then I know my perimeter is 30 square roots of 3. And again, I have all the information I need to find the area, which is apothem times perimeter divided by 2. Since this one, the 5 and the 2, you can reduce it if you want. But 5 times 30 is 150 divided by 2. We have 75 square roots of 3, and our units are inches squared. So hopefully this will help you better understand how to find the area of regular triangles. which is a polygon, and then your next video will contain the notes for the regular quadrilaterals.